Hello everyone, I'm Chris McIntosh. I help teach the statistics courses. This week we're going to go over the week 12 computer assignment. My goodness, I keep missing these pieces of text. So the objectives for this week are to conduct a Pearson correlation in Jamovi, and interpret and report the results for Pearson correlation, and we'll also see how to get a base factor for a Pearson correlation. So you're going to open the data set in Jamovi. So let's get Jamovi open. And you should have already installed the LSJ data module to be able to see these. And you're going to go to the hamburger menu, open data library. And I just noticed this week that these data sets have the Jamovi chapter included. So you can zoom down the list to chapter 12. And we want this parenthood list. Okay. And put your name at the top of your output. So go to analysis, exploration, descriptives, just to get some output started. Click in the output right in front of results. So your cursor's flashing. And add your name there. Alrighty. Let's see what's next. You want to go off of the statistical analysis checklist. I have the link to it. We're using the week 12 correlation checklist. The questions in section number 1, the study information. Study purpose. If this were real, you'd have a purpose that you were shooting for. This is just a learning exercise, so data are fabricated and results are not generalizable. Research questions. This didn't really have a particular research question listed, but typically you'd be answering some kind of question. What's the relationship between some variable X and some variable Y? So that's typically what you're going to see for that. Study design, no elements were described in the chapter for this data set, but typically correlations are used in descriptive study designs. So often not experimental research, quasi-experimental or even pre-experimental, just a descriptive design looking at what's going on with people and writing it up. And you'll also see them used often checking assumptions for regressions. Ethical considerations, nothing was described for this example. Data collection, handling, also nothing described for this example, but you would write those up for a real study or a real project. Answer the questions in section number 2, the data set information. So variables and level of measurement. So you would get in and take a look at these variables. And we're going to actually talk about a couple here. So you'll notice here there's an ID variable and a day variable, and you'll see those have the exact same numbers in them. And you might kind of wonder what is going on here. And so this is a little bit different data set than you might encounter typically. So this looks like they're measuring the same person over time. So this ID is just an observation ID. If it were separate people, they'd be separate people IDs. But notice how Jamovi has this listed as that little ruler means it's a scale level or a continuous level. And an ID is a unique ID, and you'll notice that all these numbers are different. So we'd actually have the ID variable listed as nominal. Jamovi has an ID category. Not all statistical software does. So if you didn't have an ID category, let's go ahead and make it ID just for fun. then you'd pick a nominal because it's dividing people into groups, and they just happen to be groups of one. They're their own. Each person is its own group. Uh, Data type integer. That's fine because that's what those numbers are. And then we have a variable called Dan sleep, which is maybe how much time they were able to sleep, and we see that's marked as continuous. Baby sleep, how much time a baby slept, and I believe this, I don't know how well this data set's described in there, but I think it has something to do with having a child or a baby and getting sleep. Dan grump, I'm guessing that's how grumpy they were. And this one is a number, and it's rating this on a scale, and so you'll see these numbers go pretty big, and I would typically call that, you'll see that Jamovi has this marked as nominal, and that's continuous because kind of a psychometric or rating feelings would be kind of an interval level of measurement. So if I were picking one, I'd pick interval for that. And then day, we're looking at how many days have gone by as they're measuring, and so I would actually call that one continuous. I'd call that ratio, level of measurement, and integer, that's just fine. Okay, and to see if we have any issues, this is a small data set. We can skim down and see pretty easily and quickly if there were any missing data. Although, are there any like crazy values in there? We just use descriptive statistics to look at that. So let's click back in our output in descriptives, and let's go ahead and get descriptives for all of these continuous variables. And these are not categorical data, so we don't care about the frequency tables. We've got mean and median, standard deviation. We know we're looking at correlation. We'll learn that normality is an assumption for correlation, so we're going to click on the Shapiro-Wilk test just to get a quick idea of our normality here. And then go ahead and do plots, and for continuous data, what are the plots that we want to see for that? Hopefully you said to yourself histogram and box plot. So as we take just a skim over this, we see we have 100 observations, no missing observations. That's pretty nice. Means and standard deviations. You can see there's some differences in standard deviations on these. And Shapiro-Wilk test, nothing was significant except for day. That's significant. So when we get down to look at that plot, let's see what we can see that this is not normally distributed. So sleep, that's, got a peak in the middle, might be a little flat, but it wasn't different enough from normality to get flagged as significant difference. No outliers on that box plot. Baby sleep also peaked in the middle and no outliers. Grumpiness, grump, peaked in the middle, no real outliers on that one. And day, you'll see it's just counting a sequence of days, and so this is a very flat distribution. So that's why that's testing as not normal on the day. So no outliers, but it's interesting to look at. Okay, not doing any data manipulation. We said there's no missing data. We didn't see any outliers, and we saw our descriptive statistics in there. So test information. So we have been building our checklist week to week, and we've got our table up here for which test should I use. And yep, this is week 12. So you'll notice that we added in, I marked the new ones in red. So our outcome variable is interval, and our independent variable or predictor variable is also interval and ratio. And so you'll see we've added Pearson correlation for the interval and ratio levels of measurement for those. And if you have assumption problems, then a Spearman row would be a non-parametric equivalent for a Pearson R. Rho is Greek for R, basically. And you'll know from the reading that ordinal data can be looked at a relationship for ordinal and higher levels of measurement using a Spearman row. So we've added a Spearman row just to the ordinal row there for our ordinal outcome with whatever combination of predictor variables you're using. So that is a nice way to look at that, but we can look at this in Jamovi. So let's get our data set over here and go to StatCat, and this we're looking at relationships. So correlations are relationships between variables. So we'll pick that one. And you can pick any two continuous variables. We're just looking to see what test we can use here. And you'll see that it identifies these as continuous variables and a Pearson correlation. And it also identifies linear regression, so because that's also looking at some relationships, doing some prediction with it. And I do not see that it identified Spearman row as a non-parametric equivalent, but this is close enough. And I'm sure if you ask ChatGPT, it'd probably give you Pearson R as the test that could be used between two continuous variables, and with some other options, because as StatCat noted, there are some other options there. Okay, independent and dependent variable. These are both continuous test assumptions. Samples are randomly selected from a population. You know that from study design. What's the sampling strategy used? Observations are independent. You know that from the study design, whatever was described. This one's a little bit different, this sample data, because this looks like it's probably the same person measured, but you can still calculate a Pearson R for this. Data are normally distributed, and most of our variables met that assumption except for day. Variables have a linear relationship. That is something you're going to know from the scatter plots. So we have not done scatter plots yet, but let's look at exploration. So analysis, exploration, and scatter plot. And you have to do one variable at a time for this scatter plot option. And depending on how many variables you have, that can get pretty tedious. So we're actually going to get another way to get several scatter plots at once. So we're going to go to analysis, regression, and this first one, correlation matrix. And let's go ahead and put all of our continuous variables in here. If you had a very specific research question, then you may be focused on the relationship between two of these variables. If you're looking at assumptions for other analyses or just general descriptions, then you might be interested in looking at all of these at the same time. So once you have your variables moved over, if you scroll down a little bit, there's an option here to get a correlation matrix, and we're going to go ahead and check that. Or we get the plots for the correlation matrix. And here are plots, and this correlation matrix, the way you look at this is you look at the variables in the columns. So you can see we have 4, Dan sleep, baby sleep, Dan grump, day. And you'll see the same 4 variables listed in the same order in the rows here. Dan sleep, baby sleep, Dan grump, day. And what we're looking for with linear relationships is you'll see how all these dots on the scatter plot kind of form a line. And we can see between Dan sleep and baby sleep, then here's our dots. And I don't see any problems with our linear relationship. When you have a curvilinear relationship, and I showed you an example in the lecture slides, you'll see this kind of horseshoe shape or some other, could be other curves in there. And then sometimes you'll see like down here, just these clouds. These are pretty indicative of low relationship variables when things just like a big group of dots and there's not a huge pattern to it. This day and baby sleep is really flat, so this is going to be a really low relationship. So I don't see any problems with linearity. So that's how we would look at that. And then homoscedasticity. We're going to talk a little bit more about that. And again, we would look at a scatter plot for that. And I will leave this discussion of this one for just a second because I've got a separate slide for homoscedasticity. And then our NHST steps, we're going to write our null and alternative hypothesis. And our null is there's no relationship between the variables. And our alternative is there is a relationship between the variables. Criteria for rejection, we'll be using alpha 0.05. And then we're going to get a test statistic, which we have an R value, and you include the number of participants, and then the value for R, and then the P value. And then we'll decide, do we reject or fail to reject based on our P. And then there's no real post-hoc tests for correlations like there is for ANOVA, but you are going to, what's the pattern here? And an effect size for R, and I'll talk a little bit that one, so we will just move forward and look at some of these other slides. And I got those a little out of, oh, never mind. Those are in my other slides. Sorry about that. So homoscedasticity, if you look at the other slides, is the analog of homogeneity variance when you have a categorical variable and a continuous variable. And in homogeneity variance, you look at the variability from between one group and the other group, and hopefully they're about the same. Homoscedasticity is that the version of that assumption for continuous variables. And the way you judge that is you look at the low end, the x-axis, and see how much the dots are spread up and down from that, and compare that all along the way up to the high end, and hopefully the spread of dots around that other group is pretty similar. And these are pretty similar. There's a couple spots where there's a dot up or down. You don't need to worry about that. But if what you're looking for are these big funnel shapes where maybe it's really narrow at this end and then it spreads out and gets really big at the other end. And that tells you you may have a problem with homoscedasticity. These plots all look okay. I don't see huge problems in homoscedasticity. Maybe this one down at the bottom, there's kind of a bigger spread in the middle. But there's no like alternative tests. Well, you could potentially go with the Spearman row. But you just note that, and then maybe robust methods. So sorry, that other slide was in my other lecture, and I had forgotten about that. And the effect size also was in the other lecture. That R squared, or coefficient of determination, tells you the percent of shared variance between the two variables. So what you'll do to get a coefficient of determination is take the value for R. So here we've got baby sleep and Dan sleep, and our correlation is 0.628. And if we multiply 0.628 by itself, then we're going to get about 0.39, I think. And that means that about 39% of the variance is shared between baby sleep and Dan sleep. So it just tells you what variance in one variable is kind of explained by variance in the other variable. So that's a useful effect size. And just be aware, R itself is kind of an effect size, and I've seen that used for other as an effect size for other tests. And I've seen you can convert one effect size to another one, and I've seen Cohen's D converted to R's, and vice versa. So just be aware that R itself can be considered effect size in some contexts. Okay, so what is the story these data are telling you? So this is very descriptive, and to get kind of the story, what's going on here, of course, we look at our correlation matrix, and we have this table of values, and you'll notice we have a couple options here in Jamovi. We can flag significant correlations. I like to turn that on, and N, I don't need to see the N's here in this table. If we turn it on, you'll see I'll say 100. So I already knew how many people were there. I'm not going to worry about getting confidence intervals right now. So we can see that for the correlation between baby sleep and Dan sleep, that its p-value is less than 0.001, and it has 3 asterisks underneath it. And this is pretty standard convention for statistical software. For sure in SPSS, when the p is less than 0.05, you're going to get 1 asterisk. P less than 0.01, you'll get 2 asterisks. And p less than 0.001, 3 asterisks. So these significant correlations, less than 0.001, less than 0.001, less than 0.001, you'll notice those all three have 3 asterisks there. But these other correlations between day and these other 3 variables, Dan sleep, baby sleep, Dan grump, you'll notice the correlations are pretty low, 0.0 something, 0.0098, 0.01, 0.076, and these p-values are all not statistically significant. So, this had 100 observations. If we started getting into 1,000 or more observations, then even these low correlations would be statistically significant. But these are pretty weak correlations. So, remember that p-values are affected by sample size. That's one of the challenges of p-values, and that's why effect size were invented and used, because they tell us, the clinical significance rather than just the statistical significance. So, yeah, these are probably not very clinically significant because they're pretty low values. These ones, though, are pretty clinically significant. And, I wanted to show you on the plots, the scatter plot matrix. You can turn on these options in Jamovi. So often in other statistical software, you'll notice that these, where you have a variable, Dan sleep with itself, Dan sleep in the row and the column, you just get these dashes. And whenever you correlate a variable with itself, it's going to be a perfect correlation in at every instance where one variable goes up, the other one goes up by the same amount. Other statistical software, you'll see ones in these positions rather than just dashes. This and then often other statistical software, you'll see them fill the numbers in for this table, and they're the exact same numbers. They're just symmetrical around this diagonal. They call this the diagonal, where you have all the variables with themselves, and then they'll fill in these values, and you can either read the top of the table or the bottom of the table. In this case, if we saw baby sleep and Dan sleep, we could go the other way around and use the column baby sleep and Dan sleep, and there would be a value there. But Jamovi doesn't do that, and this is the preferred method in APA for reporting correlation matrix. Just do half the table. So this would work as is to go into a report. If you're reporting all these correlations, that this table would probably be the way to do it. But down here for the scatter plot matrix, we have the scatter plots for each of the correlations, but Jamovi allows us to put the densities for the variables in the statistics. So where it's the variable with itself, Dan sleep and Dan sleep, if you went back up to the histogram, you'll see that the shape of that histogram, if you put a smooth line on that, that is what you'll see down here in the scatter matrix. So it's kind of this, if you added a smooth line to the histogram, that's what you'd see, and that's what you're getting here. And so, again, all three of these, Dan Sleep, Baby Sleep, Dan Grump, were peaked in the middle and then spread out, but Day was pretty flat. The histogram was very flat. So that's what you're seeing. And then it puts the correlation values on the top of the table. And so it just makes this, you see this, this line sloping up and these dots around, and you're wondering, well, what is the actual correlation for that, rather than make you scroll up and look at the other table. It's 0.628. You can just see it right here. So the Jamovi developers did a thoughtful job of putting this together. This puts all the information you'd want to see. So something nice to look at. So which of these are statistically significant? You'll see they're marked here on this Baby Sleep and Dan Sleep, and Dan Grump and Dan Sleep, and Dan Grump and Baby Sleep are all statistically significant, and all the variables with Day are not. So, and then you just want to interpret this. So where the scatter plot makes it really easy to interpret, as Baby Sleep increases, Dan Sleep increases. And you always want to not just tell the reader that it's a positive relationship. You want to tie that back to a real meaning, and have it go to something. So if we look at Dan Sleep and Dan Grump, we see that as Dan Grump increases, as Dan Sleep increases, Dan Grump decreases. And you can say it either way you want to. You just want to make sure that the variables are opposite of each other. So you could say, as Dan Grump increases, Dan Sleep decreases. It's going to be correct. You just, positive relationships, they both increase at the same time. Negative relationship, one increases, the other one decreases. Same thing with Baby Sleep and Dan Grump. As Baby Sleep increases, Dan Grump goes down. So that's how you interpret those. And sometimes you want to be really careful with psychometric instruments. I'll just point this out to you that Dan Grump, it's a little bit arbitrary. Does a higher number mean he was more grumpy, or does a higher number mean he was less grumpy? And because it's not a physical measurement, I typically would orient this that a higher number means he's more grumpy, but sometimes, for whatever reason, people orient these the other way. And you just want to make sure that you understand that and interpret it for the reader so that it's very clear what that actually means. And that's one of the main reasons why it's not good just to say it has a positive relationship. You want to go interpret that to an actual meaning for a reader. Yeah, that's those are the patterns there. Let's go ahead and try and report these results. And I haven't tried this yet, so we will experience this together. Try and ChatGPT, and if I go get our prompt text, what I'm basically asking for, and here's the information. I'm going to hit Shift Enter to go down to the next line. Let's get into Jamovi, and let's give it our correlation matrix. I have no idea if this is going to work or not, but it's worth a shot. Control V to paste, Shift Enter to go down one line, and let's give it our descriptives table. That'll be useful. Right click, copy, and Control V to paste, and Shift Enter, And let's see if we have anything else that I don't think so. All right, let's hit enter and see how ChatGPT does with reporting this for us. Okay, so this isn't bad. Just a word, one of my thoughts as you're reporting this out, we already gave, that's a table, the descriptive statistics I'd probably include in my research report. And there's no need to be very explicit on a real report of every single descriptive statistic that's in a table. I would give the table and point out any highlights, and might say that, the general trends or pattern was that as the baby slept more, Dan slept more, and Dan was less grumpy. And that would probably be sufficient because they can go see it in the table. So you don't want to repeat verbatim everything in the table and say it in the description, the narrative description. So I probably wouldn't report that quite like that. Correlation. I like this description that, to look at these relationships, the Pearson correlations were computed. And no significant relationship with the null hypothesis. And then it goes through and gives us the statistical relationships. And let's double check that the ChatGPT got it right. Okay, Dan sleep and baby sleep, 0.628. Baby sleep, Dan sleep, 0.628. Statistically significant. When a baby slept longer, Dan also tended to sleep longer. Positive relationship. Dan sleep and grumpiness, negative 0.903. Dan grump, Dan sleep, negative 0.903. More sleep associated with lower levels of grumpiness. This was very large, indicating substantial inverse relationship. And Dan's baby sleep and Dan grumpiness, negative 0.566. Baby sleep, Dan grump, negative 0.566. Yeah, it did a pretty nice job of pulling out the right numbers there. These results suggest that Dan's sleep is closely related to both the baby sleep and his level of grumpiness. Particularly, more sleep for Dan and the baby associated with reduced grumpiness for Dan. However, time did not appear to influence these relationships. The large effect sizes for the relationship between Dan sleep, baby sleep, and grumpiness highlight the strong interplay between these factors, which may have implications for interventions aimed at improving sleep and well-being. So, and that, that these very low relationships we saw in the correlation matrix in the table, and in these scatter plots, these lines are they're almost flat. This one in the middle, baby sleep and day is flat, so there wasn't a real strong correlation there between the days and baby sleeping. Negative 0.01. I mean, that is a minuscule correlation. So about a flat line. So yeah, I think that's an admirable job. That get you far down the road if you ever have a problem interpreting this. Pasting your output into ChatGPT with a request for help interpreting is great. And this write-up, I have seen many worse write-ups than this. So with the exception of don't repeat verbatim your table to a reader, give them the highlights. So that's great. So yeah, copy. Since you went through the trouble to get it interpreted, then paste that down in your output in this. And once you save your Jamovi file, hamburger menu, save, browse, navigate to where you're going to save it, and then export your PDF output. Go to the hamburger menu, export, navigate to the right folder, and it's got a PDF, and save that. And let's make sure we got nothing else I'm wanting you guys. Save, export, answer the computer assignment questions, and submit your PDF in Canvas. So yeah, interesting looking at Pearson correlations. You see these a lot all over the place, so nice to understand them. Hope you have a good rest of your day and your week, and we'll talk to you later.